Hi, I'm Will Vlog, and this is my third video for my IBMYP project documenting my progress learning graphical user interface development with Python's library Tkinter. Currently, I've been working on an organizational application called Flow to help students better handle their schoolwork. In my previous video, I completed the to-do list functionality. Since then, I've been working on the planner functionality of Flow. While coding, I noticed that I understood the syntax of Tkinter and Python better. Syntax being the actual form of the code, like the keywords and the methods. This meant coding went by a lot faster than previously, which meant I spent more time on planning and the logic of my code instead of trying to figure out the proper methods I needed to be called. The first thing I did before I started designing how I'd like the planner to work was figuring out where I would put the planner page in my program. I found a widget called Notebook that was a special extension that allowed for functionality similar to an internet browser like Google Chrome, where there'd be tabs on the top that could be switched between. Before trying to implement this new widget into my code, I followed along with a YouTube video explaining how the Notebook widget works. I then created a small project to figure out how the widget would work in my project, and then I modified my code to accommodate for the widget. I ended up shifting everything up about 20 pixels to hide tabs that come with the widget to navigate between pages. Instead, I decided to have buttons to navigate between each page, which occupy the main action bar on the left-hand side of the screen. Now that I had a page, I decided to design the planner page, which was a lot simpler than planning the to-do list page. Now that I have a better understanding of the limitations of Tkinter and of my abilities and what I was comfortable coding, the main thing it was much easier to design the planner. The main things to note are that I kept the two main action bars that were on the left-hand side of the screen and the top part of the screen. Then I put the actual planner in the middle of the screen. Moving forward, as I develop Flow further, even after I'm done working on it for the IBMYP project, I think I'll keep the design for the same for all pages. The design period also gave me time to answer questions like, what do I want the planner to do, how do I want it to interact with other parts of Flow, and how do I want the user to interact with the planner. I opted for simplicity in what I did, which was to block periods of the day off visually so students could plan out their day with having conflicts in their schedule. I decided the best way to do this was to have the main focal point be the background with the numbers 0 to 24 to represent the hours of the day. However, how I wanted the planner to interact with the to-do list ended up complicating how the user interacts with the planner. So I wanted to have it where all tasks from the to-do list would be shown and the user would pick one of those tasks to add to the planner. This means if the user wants to add something to their planner, the first thing they need to do is go to the task page, add to the to-do list page, add a task, come back to the planner page, select the appropriate date, and then select the task and add it onto their planner. After I decided how I wanted the user to interact with it, it was easy to figure out the logic behind how the system would work before coding all of it. First, there would need to be a system to track the date for which I simply took the system I used to keep track of the dates for the sorting methods on the to-do list page. Then I added a way for the user to input a date into the box on the top left-hand side of the screen. Due to the limitations of my technical knowledge, I ended up adding a button to confirm the date, which added a function that set the date to whatever was in the box. Then I would need a way for the user to add a specific date. I resolved this by adding a list box with all the tasks they had to do from the to-do list. Putting all of these steps together, I could have the user specify on what date they would want to add a certain task. So once a day and task were specified, the user can press the add button, a pop-up would appear, and then they could specify what time during the day they would want the task to start and end. Now that I knew what I wanted my application to do and look like for it to be considered completed, I started to work on the code to materialize what was in my head and on my paper and turn it onto the computer. It started with the function called changeDate. Its whole job was to set the date when the confirm date button is pressed. However, the function will become more useful later. The second function I created was the add pop-up function that creates the pop-up prompting for the user to specify the time they want to work on the task. This function is mostly just labels, entry boxes, and buttons. When the confirm button is pressed, the name of the task, the current date, the start and end time are sent to the third function, add event. The main purpose of the add event function is to act like a translator between the times inputted and the pixel coordinates of the task in the planner. Then that information is put into an array holding all the dates and tasks associated with those dates. The final place event function will loop through a specified date, read the tasks in that date and their times, and create a frame, label, and button to show up or specified. Some of the most frustrating work came early on when I was trying to translate the time to pixels. Originally, I tried to represent every minute as X pixels. I think I estimated there was a ratio of 1 minute for every 2 pixels, so I multiplied the hour specified and by 60, then multiplied that by 2, and then multiplied the minutes given by 2, and then added those two values together to get the Y coordinate for where the task should start in the planner. This didn't work at all. Even after I tweaked several values. Eventually, I decided I needed to switch my approach entirely and see if there was another way to resolve this problem. So instead of trying to figure out the ratio of every minute to pixel, I started looking at how to figure out how many pixels were between each hour. I did this by creating an extra frame and essentially lining up the endpoints with the hour markers. This helped me determine that it was 25 pixels. So I can multiply the specified hour by 25, then divide the specified minutes by 60 minutes to get a fraction, then multiply that fraction by 25, and altogether would give the exact pixel coordinates. This was a tedious issue to resolve, and maybe my approach wasn't perfect either time, but I thought it really helped me practice problem solving and breaking the problem down and shifting my perspective about how just how many solutions there can be to one problem. The next major issue I had was with editing the task once they're placed. The task is placed, and now I want to let the user move it if they have to adjust their schedule for one day. This involved reworking all my functions to accommodate the ability to change a task already in the calendar, then instead of just add a new task. The reason I decided against just making new functions for editing is I realized that adding and editing had a lot of the same steps. Adding involved getting the user's information, the add pop-up function, process it in add event function, and then make the process information and display it in a digestible way for the user with the place events function. To accommodate the edit functionality, I created new arguments that would specify the purpose of a function. If it was to add a task, there would be a string pass called add task. If it was for editing, there would be a string pass called edit that would display the editing task. I didn't have to make this change for my place event. Either way, it was just looking through the dictionary and displaying what was stored there. Similar to a chef when a ticket comes in during order, they just read the ticket and execute from there. How editing would work is after the edit button is pressed, the same window shows up for when the events were first added, but with some minor labels and buttons changed. The user inputs the new times. Those times are processed and turned into pixel coordinates on the planner. Then I hit a not so much logical difficulty but syntax issue that definitely tested what I'd learned previously, as I've been working with dictionaries and arrays a lot. In other words, I knew I needed to somehow navigate through the array and hold all the dates and held all the dates in their respective events, but I wasn't quite sure code-wise how to do this. The first time I tried to go through without thinking too much, I didn't really have any direction or idea of what I needed to do to get to my end goal of accessing two values, the start and end time of the task, inside of an array that was inside of a dictionary inside of another array. Again, like with translating the time to pixels, I had to really take a step back and think about what I wanted to what the next thing I needed to do to reach my final goal was. This came in the form of using the command line. I created an array similar to the array with the events and tried to print various values. Once I knew how to index through arrays and dictionaries better, I was able to write it in pseudocode on paper. This is this is what the code should look like before finally going back and properly writing it in, and it worked. Finally, the last stretch for me was finishing the planner was getting rid of the events when they weren't necessary. There were several situations where you'd want to get rid of events on the screen. For example, if you change the date, you'd only want the events from the date specified, not all events in the schedule array. Or if an event is edited, all current events need to be cleared away and then run through by the schedule array again to repopulate the planner with events. The best time to get rid of these events and essentially refresh the page would be every time the place event function is called. This meant some values in the schedule array had changed. My first solution would add a visual representation of the events, the frame, the button, and the label to a list, and then I would loop through and destroy everything in that list when the place event function was called. However, that didn't work, and I think it's because all of those widgets were made inside of a function, making them local variables, not global ones. So instead, I decided to create a new frame on top of the planner backboard with all the numbers, and then I added all the events to that frame. Now I would simply destroy that frame. When destroyed, all the widgets attached to it would be destroyed too, and then I would reinitialize it and add all the new events on top again. However, it's a little repetitive in the sense that I have a planner backdrop of all the numbers, and I have the cover of it, which looks the exact same as the backdrop, but it offers a seamless transition between different dates. So now whenever the date is changed, the place event function is called. Overall, I'm very happy with what I have to turn in for my IBMYP project. It was a great opportunity to learn about how graphical user interfaces work and understand all the effort that goes into developing them, from the technical knowledge of code and the challenges that come with it to the creativity behind the design and trying to balance form and function. I think I got a lot out of the technical side of the project. I think I learned a lot about code management, the syntax of Python, and a lot of problem solving, and taking one logical step at a time when coding, slowly making my way towards a predefined goal. I really enjoyed the creative aspect of getting to draw out and plan something in my head, in my head and on paper, and bringing that idea into life on my computer. With all that said, it was a foolishly naive of me to assume I understood. It is extremely foolish and naive of me to assume I understand or know everything about GUI development. Perhaps there are hundreds of books out there with rigid industry standard guidelines on how GUI should be developed. However, I really liked how I was developing these problem-solving skills by just jumping around into the project and stumbling through and trying to figure out what worked and what doesn't. I'll definitely keep working on the flow more, even after I turn in my final presentation on this project, to see what else I can learn. Thank you very much for your time and watching me learn.